This is a quick review of the logic behind mitosis and meiosis. Everything's going to converge on this equation here. There are three numbers in this equation that you should be familiar with. The first number is the ploidy number. How many sets of chromosomes are available? Okay, and I'll show you what that means later. Let's skip to the third number. This one represents the total number of chromosomes in the cell, in the nucleus. And finally, this n number represents how many kinds of chromosomes you have. So that shouldn't make any sense right now, but let's look at this example. 2n equals 46. This is a human being. 2 means that you have one set of chromosomes from the mom and one from the dad. So that's why the number is 2. 46 means that in one cell, you'll have 46 total chromosomes regardless of the origin, mom or dad. If you do the math, you divide both sides by 2, you see n equals 23. 23 means that you have 23 kinds of chromosomes available, right? So the kinds of chromosomes is different from the sets of chromosomes, all right? Keep that in mind. Finally, there's this C number, and this number is not meant to confuse you. It's only 1 or 2, okay? It's meant to represent the copy number. If the S phase happened, then the number will be 2, all right? And I'll show you how it's represented. Basically, if the S phase happened already, instead of a figure 8, you'll have a butterfly-shaped chromosome. If S phase didn't happen yet, you'll just have a figure 8. Okay, so here you have two identical copies of the chromosome, two sister chromatids. All right, let's apply this logic to these examples to make sure we're understanding it. Let's look at this. We have 2n equals 4 because there are 4 total chromosomes, 1, 2, 3, 4, right? And you see that there are two sets, the black set and the white set. The colors in this case are representing where they came from, the mom or the dad. Let's just say that the black represents that it came from the dad. All right, so if you do the math, you divide both sides by 2, you see n equals 2. Well, that makes sense because how many kinds of chromosomes do you have? You have 1s and you have 2s. All right, and the copy number is going to be 1 because they're unreplicated yet. As you can see, they're figure 8s. All right, that's an easy example. Let's go to this one here. You have 2 chromosomes total because we're counting by centromeres, remember? So that's why this last number is 2. But why is this number 2 as well? Well, that is because you have for the kinds of chromosomes we're looking at, number 1s, you have 2 kinds available. They come in a black version and a white version. So that's why it's 2. N equals 1 because 2 divided by 2 equals 1. And why does that make sense? Well, we go back and we notice that how many kinds of chromosomes are there? There's only one kind. There aren't any 2s or 3s or 4s or 5s. There are only 1s. Okay? And finally, the copy number is 1. You don't see that there are sister duplicated chromatids that are identical, right? Okay, now it's going to get a little trickier. Let's look at this one. How many total chromosomes do you see? 1, 2. So this number has to be 2 on the right side. Finally, you'll probably be puzzled to see why this is 1. Why is this haploid? Well, it's not because there's only one color here. It's because if you look at chromosomes of one kind, there is only one set available for that kind. So if you look at the 1s, there's only one kind of number 1 here, black. If you look at the 2s, there's only one kind of number 2 here, the black one. Both of them came from the father, but it doesn't really matter who they came from. It just matters that there's one available of that kind. So that's why this is 1. Now, if you do the math, you find n equals 2. Why does n equal 2 make sense? Well, remember, the n number means how many kinds of chromosomes there are. So, how many kind of chromosomes do you see here? The kinds refer to the numbers, okay? So 1, 2, there are 2 kinds of chromosomes, okay? And the copy number equals 1. They're unreplicated. All right, let's look at this one. This example is really going to test your knowledge. So look at this. How many total chromosomes do you have? 1, 2. So this number is automatically 2. It should be the easiest, right? Now, why is this number 1? Why is the ploidy number 1? You're probably thinking to yourself, look, there are 2 colors. There's black and there's white. Then why is it haploid? This is the key difference here. If you look at the numbers, if you look at one kind of chromosome, let's look at the ones. How many sets of ones are there? There's only one set of number 1, the white set, okay? There's no other kind of number 1 around here. There's no black number 1, there's no green, no pink, whatever. There's only one kind of number 1 here. Now let's look at number 2s. How many sets of number 2s are there here? There's only the black set. There's no white version of number 2 here, like here, okay, in the example 1. Up here you have, of the number 1s, you have a black one and a white one. Of the number 2s, you have a black one and a white one. But if you look down here, of the number 1s, there's only one kind of number 1. Of the number 2s, there's only one kind of number 2, the black one. Okay, so just because you see 2 colors here doesn't mean that it's automatically going to be diploid, alright? You have to look at one individual chromosome, one kind, so zoom into number 1s and ask yourself how many sets of that kind of chromosome are there, alright? Don't try to compare it to the other kind of chromosome, just look at that, see? There's only one kind of number 1 here, therefore it's haploid. There's only one kind of number 2 here, therefore it's haploid. Okay? Now if you divide 2 by 1, you get n equals 2. And why does that make sense? Because you go back and you see that how many kinds of chromosomes are there in this cell. You have 1s and you have 2s. There are 2 kinds of chromosomes. Remember, the numbers of the chromosomes indicate the kinds of chromosomes, not the sets. The color indicates the sets. Okay, the copy number is going to be 2 because, as you could see, there are duplicated sister chromatids. Alright, now, I can ask you on a quiz, are these a homologous pair? No, they're not homologous because they're not both number 1s, or they're not both number 2s. A homologous pair would be when you have 2 of the same kind of chromosomes but 1 of each set. So for example, these 2 are a homologous pair because they're both 1s, they both have to be the same kind, and you have to have 2 different sets of that kind. So this is a homologous pair and this is a homologous pair. These aren't homologous, right? These are not homologous because they're 2 different kinds of chromosomes. These are homologous because you have the same kind of chromosome and the 2 different versions of it, 2 different sets of it, right? Okay, here's this final one. Can you figure this one out? Look at this, example 5. Sorry, you can't really see the resolution. Anyhow, you have, how many total chromosomes do you see here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means this number is automatically 9. So do that one first. The second thing you do is you look for the ploidy number. Okay? So of the number 1s, these are number 1s, 1, 1, 1. How many kinds of number 1s do you have? 3. White, green, and black. How many number 2s do you have? How many kinds of number 2s do you have? You have 3 kinds. White, green, and black. Alright, let's look at the number 3s. How many kinds do you have? White, green, and black. So there are 3 sets of chromosomes here. Is this a human being? No. Human beings are diploid, so this must be some sort of another organism that's polyploid, okay? So now we go back here and we find n. So 9 divided by 3 is 3, right? So n equals 3. That means That doesn't mean that there are 3 sets of chromosomes, even though there are. N equals 3, remember, means how many kinds of chromosomes. And why does 3 make sense in this context? Because how many kinds of chromosomes you have. Look, you have the 1s, you have the 2s, and you have the 3s. So there are 3 kinds of chromosomes here, right? Remember, kind does not mean set. And in a human being, you're going to have 23 kinds of chromosomes. You'll have 23 numbers, 1, 2, 3, 4, 5, all the way to 23. But you'll only have 2 colors, black and a white, because you have 1 from your mom and 1 set from your dad, right? So in this example, is the copy number 1 or 2? It's 2, because you see the sister chromatids. If it looks like butterflies, then the copy number is 2. S phase must have happened, right? So, okay, that's part 1.